between exponential and logarithmic graphs. So I just want to take a look at the graph of each of those to recognize that relationship. When we graphed 2 to the x, you had those on your last test. What did we plug in?
-1, 0.
2 to the -1.
1/2.
2 to the 0.
1.
2 to the first.
2.
Remember, we had a horizontal asymptote at 0, so it should look like that. Okay. If I said y equals log base 2 of x, we talked about how that you can change that to exponential form. So it'd be like saying 2 to the y power equals x. If we made a t-chart, let's plug in -1, 0, and 1. They're going to go in for y this time because y is our exponent. So 2 to the -1 is 1/2. 2 to the 0 is 1, and 2 to the first is 2. So my points, 1/2, -1, 1, 0, and 2, 1. So here's 2 to the x. I can put in any number I want for y, but will I ever get out 0 if I do 2 to a power? No. So this time, my y-axis is like my vertical asymptote. What's the relationship between these then? Starts with an I. They're inverse. If you looked at 2 to the x, the domain of that was -infinity to infinity, extended both directions. The range, it had everything greater than 0. If we said log base 2 of x, the domain, this time you're only getting the things bigger than 0. The range is going up and down forever, it's -infinity to infinity. So notice the domain of the first is the range of the second, range of the first is the domain of the second. So these are inverses of one another. So we are going to spend a little bit of time graphing our logs today, and then we'll talk about their domains a little bit, and that's really all we have to go through. So we've already graphed one log, and we saw that our strategy was to change it to exponential form. So that will be the case every time when I ask you to graph these things. So f of x is the same as y, so if I wrote this in exponential, it's like 1/3 to the y equals x. So if I made my t-chart, would you be plugging in the numbers for the x or for the y?
No.
So we'll put in -1, 0, and 1 for the y. 1/3 to the -1 would be 3. 1/3 to the 0 is 1. 1/3 to the first is 1/3. So we have 3 -1, 1 0, and 1/3 1. These, just like the exponentials always had a horizontal asymptote, these will always have a vertical asymptote. So our graph will look like this. Questions on that? If I ask for it, what's the domain of this? Zero to infinity, right? Domain is your x's, so we have only positive. 0 to infinity. Range would be negative infinity to positive infinity.
Would the 0 have a bracket?
Parenthesis. If it actually touched 0 at some point, since it's an asymptote, it will always be a parenthesis. Okay, other questions here?
What's the range?
Negative infinity to positive infinity. We can do transformations with these just like we did with the exponentials. So I want to look at a couple. We'll graph the parent function and the transformation here. So my parent function here would be like y equals log base 3 of x. If you change that to exponential, that's 3 to the y equals x. You're going to plug in your numbers for your y. So 3 to the -1 is 1/3. 3 to the 0 is 1. And 3 to the first is 3. So this is my parent function. What will this plus 2 do? It's attached to the x, so it goes left 2. Now, when we had exponentials, if we moved them up or down, we had to move our asymptote. If I have logarithms, when we move left and right, we're moving the vertical asymptote. So if I go left 2, my vertical asymptote was at 0. Now it will be at -2. And then you just move all your points. And so it should look like that. What's the domain of this one? Range? Why don't you guys try B? So your parent function is the log base 4 of x, so you're going to start out by graphing for the y equals x. If you plug in a -1 for your y, you get 1/4. You plug in a 0 for your y, you get 1. And if you plug in a 1 for your y, you get 4. So those should be the 3 points on your graph. And what's happening this time?
It's going up.
So does that move your asymptote?
Yeah.
Okay. Domain?
0 to infinity.
Range?
Negative infinity to plus infinity.
Any questions there? Let's graph. I'm gonna add one more. So we already graphed the log base 3 on part A, so we know our parent function. I'm going to just sketch that. So on my parent function, we know we have the points 1/3, -1, 1, 0, and our 3, 1. Okay. So if we take this parent function, if I put a negative on my x, what would that do to your graph? Over the y-axis. It's like making your x's negative. So if your x was +1, it becomes a -1. Domain of that?
Negative infinity 0.
Range? Questions there? Do we need more graphing problems? I'm going to go to this one. These I'm asking you to find the domain, but you don't have to first graph it. I'm just asking you to use the equation to find the domain. We can do that a couple different ways. We know that with a log, the typical domain is 0 to infinity. So if you like transformations, you might be able to look at that and say, okay, that's going to move it right 1, so my domain becomes 1 to infinity. If you like a more algebraic approach, when you have a log, we've talked about both the base and the argument have to be positive numbers. So this x minus 1 has to be positive. It has to be greater than 0. So that means x is greater than 1. So my domain, how do we write that in an interval? 1 to infinity. All right. B. All we care about is the argument. so my argument here is x, so that means x has to be greater than 0. So my domain would be 0 to infinity. Okay, C. Okay, we know that the argument has to be positive, but what do you know about an absolute value? It's always positive. Okay, but there is one number this can't equal. 0, right? If I put in a negative x, the absolute value will make it positive. If I put in a positive x, we're good. But if I put in 0, I get 0. And is 0 greater than 0? No. So my domain is everything but 0 here. So it would be negative infinity to 0, union 0 to infinity.
So if there was a number in that,
Mhm.
like a 2 or something, then it would be negative infinity and then 2 to infinity.
So you guys in here? I need 3 of them.
You saw my post.
Yeah.
Sorry.
I know. But I just want to get as much done as I can. Thank you. You're welcome.
Tell anybody that needs one. Come.
Okay. Okay, D. We know that this x squared minus 4 has to be greater than 0. We can't just solve this like we would in equation. We've solved these types of things before. This is the difference of squares factors into x plus 2, x minus 2. Remember when we looked at the graphs and made our sign lines? I thought this was a fun place to review that. So we put what makes these two things 0. What makes x plus 2 0? And x minus 2? Okay. So you could graph it real quick, or you can pick test points. Which way did you guys prefer? Test points. So smaller than negative 2 would be a negative 3. In between the two of them, maybe a 0. And bigger would be a positive. So if I put in a negative 3, negative 3 plus 2 is negative. Negative 3 minus 2 is negative. Negative times a negative. I put in a 0. 0 plus 2 is positive. 0 minus 2. And positive times a negative. If I put in a 3. How many do you think?
3 or 4 for common. Seeing people
Okay, so 3 would give me a positive and a positive. So that's positive. So we wanted greater than 0, which would be the positives. So that would be negative infinity to negative 2. And 2 to infinity. Any questions here, Jay?
So we can only do that when it comes to the
Domain. Okay. For homework, there's going to be a handout posted on Classroom, which I actually forgot to post this morning, so I'm going to do that